And I've worked in 3 soil plant testing labs, Oklahoma State, K-State, A&M, analyzed over 1 million samples. I get all the samples when things aren't growing, whether it's water, plants, or soil. And so I get the headaches. And so everybody asks me, everybody has all these different recommendations on fertilizer and soil test methods and this and that. My boss at A&M, when I first got there, he said, "Larry, I'm tired of everybody arguing about all these labs making different recommendations. Just cookbook it, make it all the same." And I got into it, computer programming, expert programs, and my uncle was a famous lawyer. He did malpractice stuff. And so the insurance companies had spent millions and millions of dollars to look at doctors' diagnoses and prescriptions, and they wanted a computer program to pick out the boo-boos. So they had spent millions of dollars. Are any of those programs being used today? Not one. It takes a human being looking at all these variables to make a decision. And so that's the same thing with interpreting a soil test or a plant tissue test. So if you can hang with me the first 14 slides or so, I'm going to go through 3 courses of soil fertility and plant nutrition. And sometimes at the end, everybody goes, "Now I see why there's differences. Maybe that's what's happening in my lawn and garden." And sometimes it's just over their head, but we're going to give it a shot. All right, basics of soil fertility and plant nutrition. Back in 1450, we had no idea what was needed to grow a plant. So Van Helmont, this is the famous willow tree experiment. He was a good scientist. He planted a willow tree in a pot, and he knew how much soil was in there, and he added water. What was that? For 2 years. So this willow tree grew. At the 2 years, he took all the soil off the root system, weighed it, and it weighed 2 ounces less than when he started. Soil's not needed. It's just holding the roots. The only thing's needed is water. So that threw us off for 400 years. So, Mr. von Liebig, he's the law of the minimum. In 1850, he's the one that really put it all together. Most of the weight of the plant is from hydrogen and oxygen from water. Carbon is the big one, from CO2 through photosynthesis makes sugars. Most of the weight is carbon in the plant. The 2 ounces unaccounted for are the nutrients that are needed. And he's the one that figured out that all these different nutrients had to be there, and if one was missing, then the plant would not grow. All right, so in soil fertility and plant physiology, these are the 20 essential elements, and we remember this as C. Hopkins Cafe is managed by my close cousin Mo. And in each class, we went through what phosphorus did, potassium, nitrogen, how it came out of the soil, translocated in the plant, and we're going to cover 2 of those, and then you can apply it to the rest of them. But we're going to make it easier. In a hydroponic solution, if one of those is missing, a plant will not grow. All right, so we're going to make it easier. So even though there are 20 essential elements for growth, there's usually 9, and people will argue, molybdenum or this and that will show up, but there's usually 9 that have shown to limit growth in the field. Now the big 3 are the first 3, and that's what's on the fertilizer bag. If it's 13, 13, 13, it's 13% nitrogen, phosphorus, and potassium. Sulfur, ammonium, American Plant Food, we're the ammonium sulfate people. We've marketed BASF's ammonium sulfate out of Freeport since 1968. Our fertilizer has slow release ammonium and sulfur. Sulfur does the same thing as nitrogen. It builds proteins. It's just needed in less quantities. Zinc and iron are micronutrients that are essential. They help in the reactions. They're needed in very small amounts. All these plants on these high pH soils, the leaves are yellow, iron chlorosis. I want to explain what a micronutrient is. In an acre of corn, sorry, I'm an agronomy guy. In an acre of corn, if you prick your finger, 1 drop of blood, there's enough iron in that blood for that acre of corn. So when we say a micronutrient, it's micro. Magnesium, very important in chlorophyll. Boron can be very toxic, but it is essential. When I've experimented with boron, the plants tend to be a little greener. Chloride, we've missed this one for years, and I still have people asking for blends made with sulfate of potash because they want potassium sulfate, because the potassium chloride they think is salt, but that's not sodium chloride. One of my colleagues, because growers for years, whether it's vegetables, lawn, garden, golf courses, on high K soils, where the labs wouldn't recommend any potassium, they'd throw out a little potassium, and it would look better, especially under high heat conditions. It turns out chloride is essential to keep the stomates full of water pressure. In other words, the way that salt or the water goes up through the top of that plant to transpire to cool the leaves, there's got to be more salt in the leaf than there is down below. So chloride and potassium are both critical in that. And so the recent research has shown that chloride really helps in disease suppression, because the way a fungus will get to the root or the leaf is it becomes leaky, and that fungus can get in there. So if they're turgid, with the salt, water runs in there and makes that cell turgid. Anyway, chloride is very beneficial, but I still have people asking for blends with low chloride. All right, so back when we were deciding how to make fertilizer recommendations and how to add nutrients, Von Liebig said for each unit of nutrients you add, you got an equivalent amount of plant growth. Metralik was a German. He said, no, when you have a nutrient deficiency, when you add a little bit, you get a big jump, and then it plateaus off. And so that was really a big fight. So it turns out Von Liebig's theories are true for mobile nutrients. Nitrate, sulfate, and chloride do not attach to the soil. And so as the water transpires to the top, that's how it gets to plant. And you actually have competition where there's no roots because they're drawing water through there. So when we add our soluble, the phosphates, the potassium, limestone, zinc, iron, they do not move down with water. They have to be incorporated into the soil. The roots have to come in contact. That's why it's critical when we're establishing these plants, whether it be planting a lawn or a rose bush or flowers, to incorporate the P and the K and the lime in that soil. Even though I know everybody has these water-soluble fertilizers, and I saw a jillion recommendations on roses here in the last couple of days, and I could tell that they thought if they've got a water-soluble fertilizer, if they put it on the soil, it would move down. No, that phosphorus and potassium will stay on that surface. Now, if it's very coarse and it's really not a soil, it's a potting media, yeah, it'll move down a little bit. But it's critical to get the P, K, and lime incorporated, at least 2 or 3 inches. All right, let's go through so soil testing. Nitrate, sulfate, chloride. We can take that soil, extract it with water. We know how much nitrate's there, sulfur, chloride. We know how much the plant needs. It's an addition subtraction. So most labs agree on those recommendations. Here's the tricky part. And we're going to go through the phosphorus chemistry, and then we'll move on. All right. In the soil, at least 99.9% of the phosphorus in that soil is in a solid phase form. Soil water is 0.1%. And so there's an equilibrium reaction. In chemistry, when this takes up this amount of phosphate, then the soil will release. This is on a normal soil. So in soil testing, different labs use different chemical extractants to get a measure of this top arrow. So different labs use different methods. So that's first one reason why it's hard to interpret. All right, this is a normal soil. In our high pH soils, a lot of that phosphorus and potassium, I'm just going to do the chemistry of N and P so we can get through this. But on these high pH soils, high clay soils, a lot of that phosphate and potassium gets taken up.
So when you mean high pH, what is high pH?
7.5 and above, especially if it's got free calcium carbonate in it. High calcium soils, above 7. All right, so the different labs will take they try all these different chemical extractants then they go out and calibrate the test. So this is a, I don't know if it's corn, that's a corn crop. So you have 0 phosphorus plus phosphorus, and the Malic 3 soil test is 10 part per million. There's a long history, Adolf Malik's soil testing methods. So this is on sorghum, and you do this on all the different crops and all the different fields. And so at that 10 part per million, we added phosphorus fertilizer, we doubled our yield, and so we do all these different plots, and you get a little curve like this. And so where it breaks off, that's what you call the critical level. Now, university lab will say, if you're down here at 5 part per million, this is low, medium, and then when you get to here, it'll say high, because the chance of getting a significant response is less. Okay, you realize we're only 85% of maximum yield where the university cuts it off because of variability out in the field. Private labs will say, well, it plateaus out here, and so their critical level might be at 44 part per million. So they would go low, medium, and high. So that's 2 different interpretations of the same test. So when I got to American Plant Food, I came out of the university system. When I got to American Plant Food, I saw garden samples, lawn samples, turf farms, sod farms, and all of them were applying extra phosphorus and extra nitrogen above what the university would recommend. And if you're paying, how to put this, $3,000, $5,000 in property taxes, you want a green lawn, you should be able to have your phosphorus at 80 to 100 part per million. You're not causing any problems. Because that original low, medium, high was based on corn and wheat grown in Lubbock, Texas in 1974. And so what I found out is the sod producers, everyone producing and making money, in other words, their plants were green under cooler temperatures. They grew into the fall further. They were the first ones to come out in the spring. They had elevated fertility levels. All right, so here's our problem. See, this is just in Texas. So we've got all these different soil types, so you're trying to use one method on all those soils, on all the different crops, or every plant that's growing. That's pretty tough. All right, so one of my favorite professors, friends, he was a famous guy from Auburn. I was sitting in the, I guess we're at the national meetings, and he's a crusty old guy, Fred Adams. And I was telling, talking about all this, and I was supposed to make it easy and make everybody run the same methods. He said, Larry, don't worry about it. Soil testing is high, and plant analysis is highly empirical. It's 50% science, 50% experience. It takes someone in the area or in the, whoever is growing roses or whoever's growing what, experience using those soil testing methods. All right. I've got a problem. Well, there's different methods for those different nutrients. Now, everyone wants to use one method so they can get the sample in and out of the lab. So I just told you how we calibrated all that soil test. And so what some of the labs have done is they took the Malic 3 phosphorus test and started analyzing for everything. And so that M3 there means Malic 3. So they're using the Malic 3 on all these nutrients where there's no data. And isn't that a pretty little graph? It looks great. But I've got very wealthy people sending me the information like that. I said, I can't do it. So that costs $10. To do it the old way, it's probably $25. But anyway, we're cutting corners. All right. I use Servitech Labs. They do a really good job on the soil samples. Use the old methods, and on the roses, if you have a potting media, they do a saturated media extract where they just use water, which when I'm saying soil, it's soil. Potting media is totally different. Compost potting media, do the saturated media extract, and they can do that too. They've got a lab in Dodge City, but I'm using the one in Amarillo. All right, tidbits on soil fertility. pH and moisture affects nutrient availability. What is exactly soil pH? Acid fertilizers. What is a chelated micronutrient? We're going to get into chemistry. Hang with me. Root exudates, phytosporiferous, phytosiderophores. When I was doing my PhD research, it was amazing how different species were adapted to different soils. And it looked like those plants and the tips of those roots would exude a compound that would try to extract a nutrient. And it was like an amino acid. It would go, if it was short of iron, it would exude.
Oops, you just lost your mic.
Yellow.
Oh, no.
Okay. Anyway, there are people selling compounds that enhance nutrient uptake, and they're hit or miss, and that's Nutrisphere and Avail, and we'll touch on that just a little bit. All right. At low soil pH, iron and manganese are highly available. If you're at pH 5.5, even if your soil test, it probably won't say low, but you'll never get an iron and manganese response. At high pH, iron and manganese are not available at all. Moisture, when it's wet, manganese goes through the roof. When it's dry, manganese goes down. Iron's just the opposite way. So we're trying to do this soil test on iron and zinc, and our moisture is affecting it. So when I'm interpreting iron, I'll just add this. This last spring, we had record rains in Texas. I mean records. And we had more iron chlorosis than I've ever had in 35 years. When those soils are saturated, we were getting rid of all of that iron. And it took till August, even though it dried up a little bit, that affected it all the way through the middle of the summer where we were getting iron chlorosis. I mean on all species, because of when that soil was wet. So I had to change my interpretation of that soil test. In other words, what used to be during a drought would be okay for iron, it wasn't with this high moisture. Okay, what is soil pH? That's what I got my master's and PhD in. It's the negative log of the hydrogen ion concentration of a liquid solution. Yes, sir.
Exactly right.
Okay.
Has to do with the logarithm.
All right. So, but that's of a liquid. A soil's a solid. So when we add water to a soil and stir it up and stick a probe in it, we have no idea what we're measuring. We really don't. But it's probably our best soil test because it's an indicator of soil fertility. On the acid, older soils, more leached, they tend to be acid. So even though we have no idea what we're measuring, it's probably our best soil test. All right, logarithmic. Oh, I don't have 1 foot tiles. Dang it. Okay, we've got 1 foot tiles in here. I'm standing on pH 7. 10 foot over there is pH 6. And this is how I explain it to my ag guys whenever I recommend 3 or 4 tons per acre of lime and they just think I'm crazy. So 10 foot over is pH 6. 100 feet over is pH 5. Out in the parking lot's pH 4. So when they go from a 5.5 to a 5.2, yeah, there's some acidity there. When they hit 4.9, 4.7, that 3 tons is a drop in the bucket. They just don't understand it. All right. Those chemists. All right, when we get acid soils, and whenever you add nitrogen fertilizers, you're going to get acidity. And this is what I did on my research on wheat. When the pH got to 4.7, the plants just basically died. You have soluble aluminum. Soils have clay in them. They're aluminum silicate minerals, and the aluminum comes out of the clay, and it's a heavy metal. It's toxic to the root, and every time the little root, you have no little fibrous hairs that's trying to grow. And so that's why acid soils are really bad. Sulfur plays a role because it'll react with calcium and leach down. So nitrogen will do some of this, but nitrogen and sulfur together will drop the pH, especially on sandy soils. All right. Now, everybody talks about different nitrogen sources, and everyone, the urea guy says his is the best, ammonium nitrate says his is the best, I say ammonium sulfate's the best. They react differently in soil. When you add urea or ammonium nitrate within 7 days with good moisture, all of it's in the nitrate form. With ammonium sulfate, it takes 21 days. So our ammonium sulfate blends are not a legally slow release fertilizer, but when you apply it, there's just not a flush of soluble N that goes with the water. It's somewhat slow release. Okay. a chelated iron. Iron gets tied up in the soil quickly, a lot of nutrients do. And so in Texas, in the feed and fertilizer control, they don't want to regulate what's a true chelate. They just want to say total iron, and I don't blame them. It's kind of a hot topic because a true chelate, which surrounds this iron, is very expensive to make, but it works very well. Now, we've got some products in zinc, all of these micronutrients. A true chelate is very good and very expensive. We have some people in Texas that are adding some citric acid or a little oxalic acid, and yeah, it's kind of chelated, but it's not a true chelate. So look on that label and look for EDTA or DTPA. Look for 4 letters. If it says citric acid or something in there, it's not a true chelate.
Question.
Yes, sir.
Just what does chelated mean?
Well, here it is. See this compound right here? See these negative groups?
I never could balance those equations.
Well, anyway, these little negative groups come over here and get his positives. They're a heck of a dance partner. How's that?
Uh-huh.
They're a dance partner, so the soil can't get to him. Does that work?
Yeah, I use chelated iron
Okay.
every time I liquid feed.
Okay.
But I didn't know what chelated meant.
Sorry, this little thing grabs him. Keeps the soil from grabbing the iron. Okay. So, there are these compounds being sold as nutrient enhancement uptake compounds. The Nutrisphere is one, it's a long amino acid. Avail is a cousin of this, and some of these are being added, and when it's a hit or miss deal. When it works, it's just amazing. Bigger root system, healthier plant, everything's higher in the plant. Other times, it doesn't work. And my theory is to take up a nutrient, here we go with plant physiology. Whenever a nutrient is taken up, it has to go through this Casparian strip. This Casparian strip is these long hydrophilic acids, and they're kind of together. It's kind of like cardboard, and there's holes, there's keys. And so ammonia or nitrogen might go through one spot, phosphate another, potassium another. I really think that these, I'll just call it chelate, the Nutrisphere and Avail type things, they're grabbing a nutrient, phosphate, or nitrogen, and they're going through another door. So in other words, instead of having one door for nitrogen to go in, there's 2. That's my theory. And then it varies on the species, whether it has that door.
I actually don't want to ask you a question.
No, please do.
Are you familiar with Nitron Industries?
A little bit.
They have a product called A35.
Okay.
I don't even know if it has an NPK problem. I don't know. But we use it, and the whole purpose is, they won't tell you what's in it, is to help the plants take up whatever nutrients you're putting in there.
Okay. There's several.
It was kind of a catalyst, so to speak.
Yeah, they're long amino acids. Everybody's kind of trying to get in, jumping on this bandwagon, and
Well, they've been doing it for years.
okay. Well, it's becoming a hotter topic.
Okay.
Okay, I'll look that one up. All right, root disease. All of my complaints where nutrients are taken up, it's usually a root disease. Whenever the plant is not healthy, whether it's heat, stress, whatever, the roots get leaky and the fungus gets in there. All right, so this is in a grass, healthy Bermuda grass. There's a steel and cortex. And whenever you have a fungus infection like the GGG, it infects in there. And then that's what Bermuda grass looks like, or this is coastal. But anyway, a lot of plant species, when things aren't growing, you dig it up and you look at those roots, they should be nice and white. If you see the dark color on the outside, take your thumb, scrape along there, and if it kind of slides off, that means a fungus or a root rot is working on that plant. And we're in big trouble when we get there. All right, root disease is normally associated with plant stress, hot temperatures, leaf loss, and high urea or high nitrate is usually, the fungus love high soluble nitrogen. So fungicides not exactly work the best, a little bit. The only management practice is to lessen the plant's stress going into dormancy or going through the winter months, and ammonium sulfate has been shown to fight some of these root rots. The fungus does not like the ammonium for some reason.
Barry, could you go back one slide and let me ask a quick question? You're talking about there, the root disease is normally associated with stress. Stress due to hot temperature, stress due to heat loss.
Any kind of stress,
Leaf
low
loss.
pH, yep.
So if you get black spot and let the leaves fall off,
Yep.
you might have a root disease
Come
around
later.
because
Yep.
of that.
Yep, come later.
Thank you.
Yep. If you have a healthy foliage sending sugars down to those roots and good fertility, that root can resist that fungus. The fungus is always in the soil. But whenever you don't have a good foliage, for whatever reason, the roots go, I've got nothing to go on. Especially, and this is a problem. Then everybody goes, well, leaves are turning yellow, they're dropping off, I'll throw a bunch of fertilizer on it. And sometimes that'll kill it. Worst thing in the world. All right. Okay, most important time for the health of most plants is the growing conditions 4 to 5 weeks before going dormant or going into the winter. That's when the photosynthesis translocates large amounts of carbohydrates and sugars. I can't tell you how many people call me and said, I followed the soil test exactly and everything's dying. That's just no fun. That's not a fun phone call. All right, real quickly, I want to cover what's going on in the fertilizer industry, and you may say, why? We've got food inflation big time. People aren't talking about it, but our country has shut down 70–80% of our nitrogen production, phosphorus production, and potassium, and all the companies that used to compete, there's only 1 or 2 left. When I first started at American Plant Food, I had a meeting with a bunch of county agents. It was five county agents, and at that time, they said, they were saying, everyone's selling fertilizer at less than cost, and they were laughing about it. They said, that's just good for the farmer. And I went back and told Mr. Ken, and he worked for Arm & Hammer and was underneath MacArthur in World War II, and he was a crusty old guy. And he put his Wall Street Journal down, and he said, Larry, if I was a younger man, I'd buy the assets of farmland and Mississippi Chemical, because in a couple of years, there's only going to be 2 companies making each one. And boy, was he right. And so this is in the 70s, is how many companies were selling nitrogen. So top 5, this is right now, this is a lot less. Potassium, 90, we're down from 33 to 7, it's less than that. And just a few companies are taking the top 3. So now, CF Industries bought Terra. This is North American nitrogen, which is ammonia and urea, which goes into all the fertilizer, which affects our food prices. CF bought Terra for $4.7 million. And so now the top 2 have 70%. That's not good. Phosphate closed, 74% is one company. We have to go to Florida to get our phosphate. The old Olin on the ship channel, 750,000 tons of phosphate per year because of those gypsum problems. They had to shut down. So now we got to go to Florida instead of across the street. So that means we got to ship it from Florida to Galveston to up through Texas, so that increased the cost of phosphate big time. And there's potash. Okay. Whenever I give speeches, I always talk about what's going on in China, and I got yelled at Tennessee Colony, little bitty fire department. I mean, this kid got red in the face. He said, I don't give a blank what's going on in China. I know you're blanking us. But China is a player. They're 53% of the world fertilizer demand. They're building a urea plant, 1 per month. So if they export urea, shows up in New Orleans, price plummets, which that's what's happening now. But if they decide to keep it over there, they need it for rice in India or wherever, then we've only got 2 producers in the U.S., so price goes up. So here's the global urea production, and here's North America. But with the cheaper natural gas, and people paying so much for urea and anhydrous ammonia, it's the pendulum switching back the other way. So the Coke guys, they bought the old farmland outfit at Enid. It's the biggest expenditure, even for Coke. They spent $1.6 billion in Enid to increase their urea production. Agrium has increased in Border. This one was interesting. CHS was going to build a $2.5 billion plant, but somehow the Cokes bought the company that was going to supply them the energy. They play hardball. All right, now our friends down at Freeport, American Plant Food is kind of we're part BASF, and they got tired of getting ripped off on their ammonia prices, so they're finally going to build, they should have built this 30 years ago, but they're going to build a $1.4 billion nitrogen plant. And we need that for Texas. And I don't know if, I'm just going to, don't
Just
take,
tell us where does that come from, the nitrogen? Like they're gonna build a,
it's the it's the German process. They use natural gas
oh, okay.
and a synthesis, and they take nitrogen out of the air and make NH3 gas, ammonia, anhydrous ammonia, and it goes to urea, ammonium sulfate, and ammonium nitrate. I'm going to step into my organic deal here. The organic term is really being misused. It's almost like a religion. Just hear me out. There's more natural carcinogens than man-made carcinogens. Nicotine. Okay. So whenever I say, organic, 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 I don't know how to tell you this, but half the nitrogen in your DNA, in your blood, in your skin, is from synthetic nitrogen from that process I just talked about. So if we hadn't had that, the Germans invented that in 1880. The reason was for building bombs. Trinitro, TNT, anhydrous ammonia can be made to make TNT. But anyway, that enabled us to, do the food, the green revolution. So organic. If somebody wanted to say, I don't want pesticides on my food, I kind of understand it. If they say herbicides, even though all the herbicides have been tested, I can understand that too. But to say organic fertilizer, synthetic fertilizer should not be associated with that bad organic term. It costs a lot of money to put the fertilizer in those little containers to handle thousands of tons. So that little granule in that bag or whatever, it takes a crystallizer. Our crystallizers at BASF have been there since 1968. They weren't working efficiently. We had to buy 2 new crystallizers. That's $32 million. You get it made, you got to ship it to Canada for canola, Idaho for the potatoes, to California for the, we fertilize a lot of avocados and nuts, pistachios, that's the one. And so we had to buy 200 new aluminum rail cars. So that's a lot of money to get fertilizer around this country, which makes our food and fiber cheaper than everybody else. Okay. Fertilizer. High P, there's 2 camps. The high P for bloom, there's the old 10-20-10, 12-24-12 type people. Then there's the high nitrogen, or higher end, 12-4-8, 16-4-8, 15-5-10. 3 tablespoons per plant per month, March through September, 12 to 18 inches. What I really like and would like to promote today, I like the 5 to 6 holes around the drip line. Make a hole with a crowbar or rebar about 1 foot deep, fill with triple 13. Every 2 to 3 years would be plenty. Just think about that. You're making a tree spike,
Yeah.
and you're getting the P and K and everything, micronutrients down there where it's at. Now, as far as fertilizers,
How deep is the hole?
12 inches.
And how far apart is it?
Just go around in a circle, foot
And
and a
that's
half.
not around a tree?
Yeah, yeah. For years, I've wanted to make my make a fancy triple 13 with all the magnesium and copper and manganese and boron. I know it's hard to read up here, but they finally let me, but my Aggie bosses, I had to have the maroon plant food up there. I wanted orange to match in here, but anyway, that's our garden basket. And that'll grow anywhere. It's not slow release, but it's got everything but the kitchen sink in it. Work everywhere. So, that's been very successful. They've been putting it on lawns, getting the lawn of the month green. And recently, about 3 months ago, these startup company guys from Katy, Texas came to me and they said they know very little about soil fertility or soil testing. And they said, we want to concentrate on trees. We've got all these trees and these resorts and golf courses not doing well. And limited water. And they said, make us the best fertilizer, no holes barred, add all the ingredients. I said, okay, let's take my triple 13. And now what I forgot to mention, on the organic side, okay, I may have it slide here in a minute. Whenever you have high yields, the plant's doing the best, is it the synthetic fertilizer or is it the organic fertilizer that does the best? If you put them together, there's a synergistic effect. All of these record yields, record plant growth, it's usually part organic and part inorganic. So I said, why fight it? So we took the triple 13 that had everything in it, and originally I had 1/3 poultry litter, and then they wanted to add, let's see what we got here, indole-butyric acid, a hormone, vitamin B1, Aquazorb, that's the same stuff as in baby diapers that absorbs water, and then mycorrhizal to help the roots. So we put everything, I mean, all those little additives into this AAA. And so what these guys are doing, they're promoting and they're getting successful. They went a little overboard on my tree spike recommendation. They went 3 rounds and 2 foot apart. I think that's overkill, but that's what they're doing. But anyway, that's our AAA. And they modified it the other day. It's not 1/3 poultry litter, but it's 20% poultry litter and 10% Aquazorb. They got to thinking they're going to Arizona and drier areas where water's limiting, and they're adding more Aquazorb, and that's fine, and that's very expensive. But anyway, it'd be hard to get a hold of, but that's my, I like this. I think it's going to work. I think it'll grow anything. But anyway, TreeNutria.com. Okay, so all this lawn fertilizer out there, organic, organic, organic. I went and got the best organic lawn fertilizer I could get that's actually certified in California. It's bat guano. It's got some alfalfa meal in it, but those compounds are very, very slowly available to nitrogen. The microbes in the soil, there's just not enough nitrogen. So it's hard to see in a slide, but anyway, this is the organic, and the disease was a lot worse. And this is our K8-15-510 right here. These plots had 2% nitrogen. The fertilized plots had, or the 15-510 had 2.7%. So 8 weeks after application, 1/3 extra nitrogen. I mean, the chlorophyll was much, much higher. But again, I put a little strip. I didn't take a picture of the K8 and the organic together. It looked a little better. All right. Sorry, guys, for the chemistry lesson. Yes, ma'am.
My roses, I live in a high clay area up in Canada, in Calgary, but my roses show magnesium deficiency. And I have been pouring Epsom Salt, so nothing happens.
On the surface?
No, and I put it in water, mix it up and pour it in and.
On the surface.
Yeah, on the surface?
It's going to stay right there on the surface.
Oh, okay.
Yep.
So, do I need to put it in water? Can I just dig it in and?
You
dig it
need
all
to
around?
incorporate. Magnesium's got a positive charge. It's going to react with the clay right there.
Oh, okay.
Only the negative nitrates, sulfates, and chlorides move with the water.
Oh, okay.
All the potassiums, the calciums, the magnesiums, the irons, the zinc, they react with
How
that
do I
soil.
get it down there then?
That's why I like my little tree spike.
Oh, okay.
Yep.
Thanks.
And it's critical at planting to incorporate it in
Oh,
that bulb.
so when I dig the hole, put the rows down, dig
Yep.
some of that in?
Yes.